क्लास में देखते हैं लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम। लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम। Law of conservation of linear momentum. For the law of conservation of linear momentum, so when external force acting on the body is zero, when external force acting on the body is zero, dp by dt equals to zero. So dp by dt is zero, momentum equals to constant. That is the conservation of momentum. When external force acting on the body is zero, momentum is constant. That is the conservation of momentum. When external force acting on the body when external force acting on the body becomes zero, when external force acting on the body becomes zero, then momentum is constant. That is called conservation of momentum. That is the conservation of momentum. When external force acting on the body is zero, then momentum is constant. That is the conservation of momentum. So deduction of conservation of momentum, deduction of conservation of momentum from Newton's third law. Deduction of conservation of momentum from Newton's third law. Deduction of conservation of momentum from Newton's third law. According to Newton's third law, F12 equals to minus of F21. According to Newton's third law, F12 equals to minus of F21. So that is according to Newton's third law. F12 equals to minus of F21. F12 is dp by dt equals to minus dp by dt. So this is d by dt p1 plus p2 equals to 0. As dp by dt is 0, d by dt p equals to 0. So momentum equals to constant. Momentum equals to constant. That is the conservation of momentum. Deduction of conservation of momentum from Newton's third law. F12 equals to minus of F21. So dp1 by dt equals to minus dp2 by dt. So that is d by dt p1 plus p2 equals to 0. dp by dt equals to 0. Momentum equals to constant. That is the conservation of momentum. So next is application of conservation of momentum. Application of conservation of momentum. So what are the application of conservation of momentum? First is a recoil of gun. So what are the applications of conservation of momentum? First one is recoil of gun. Recoil of gun, explosion of bomb, then rocket propulsion. So these are the application of conservation of momentum. So first is recoil of gun. That is the recoil of gun. For the recoil of gun, this is the mass of the gun is m, speed is capital V, recoil speed is capital V, and this is the bullet. This is the bullet. Mass is small m, velocity is small v. So this is the mass is capital M, velocity is capital V, recoil velocity is capital V. So mass of the bullet is small m, speed of the bullet is small v. So as this is the concept behind conservation of momentum, so in this case momentum equals to constant. In this case momentum is constant. As momentum is constant, change in momentum equals to 0. In this case momentum is constant. As momentum is constant, change in momentum equals to 0. So change in momentum is 0. Change in momentum of bullet plus change in momentum of gun equals to 0. So change in momentum equals to 0, that is change in momentum of bullet plus change in momentum of gun equals to 0. So what would be the change in momentum of bullet? Change in momentum of bullet equals to how much? Change in momentum of bullet equals to m, that is v minus 0. That is the change in momentum of bullet. Change in momentum of gun, that is m, v minus 0. So that is small m into small v plus change in momentum of gun, that is capital M into capital V equals to 0. So capital V equals to how much? Capital V equals to minus small m into small v divided by capital M. Capital V equals to how much? Minus small m into small v divided by capital M. So that is the recoil of gun. That is the recoil of gun. That is the recoil of gun. V equals to minus small m into small v divided by capital M. That is the recoil of gun. That is the recoil of gun. This negative sign indicates that both moves in opposite direction. Negative sign indicates that both moves in opposite direction. Negative sign indicates both moves in opposite direction. X is the mass of gunman. X is the mass of gunman. अगर गनमैन जो है बॉडी के साथ अटैच करके फायर कर रहा है तो उसके लिए ये फॉर्मूला होगा -mv डिवाइडेड बाई m प्लस एक्स। और ये जितना मास ज़्यादा होगा रिकॉइल स्पीड क्या होगा, रिकॉइल स्पीड जो है उतना कम होगा। जितना ये मास जो है ज़्यादा होगा ये रिकॉइल स्पीड जो है उतना कम होगा। सो दैट इज़ द रिकॉइल ऑफ गन। नेक्स्ट देखते हैं रॉकेट एक्सप्लोजन ऑफ बॉम्ब। एक्सप्लोजन ऑफ बॉम्ब। एक्सप्लोजन ऑफ बॉम्ब में सपोज एक बॉम्ब जो है दैट मास इज कैपिटल M, स्पीड इज 0 and it explodes into two parts. Mass is m1, speed is v1, mass is m2, speed is v2. So using this concept, initial momentum equals to how much? Final momentum. Initial momentum equals to final momentum. Initial momentum is m into 0. Final momentum is m1 v1 plus m2 v2. So that is initial equals to final. So 0 equals to m1 v1 plus m2 v2. So from this we can calculate the speed. So that is explosion of bomb. So if bomb explodes into 3 pieces, so that is the mass is m, speed is 0. This is m1 v1, this is m2 v2, this is m3 v3. So m into 0 equals to m1 v1 plus m2 v2 plus m3 v3. 0 equals to m1 v1 m2 v2 plus m3 v3. If it explodes into n number of pieces, so that is explosion of bomb. So next is if after explosion it moves into n right angle to each other, so that is m, speed is 0. If it moves right angle to each other, so this is m1 v1 m2 v2, this is m3 v3. So this is momentum is p3 and this is the resultant p1 square plus p2 square root over. So here we can write p3 equals to pr, p3 equals to minus of pr, p3 equals to m3 v3 equals to minus pr equals to how much? P1 square plus P2 square root over. So that is the M3 V3 equals to P3 equals to minus of PR. M3 V3 equals to how much? M3 V3 equals to resultant of minus root over of P1 square plus P2 square. That is the conservation of momentum for explosion of bomb. Next is rocket propulsion. So next is rocket propulsion. In case of rocket propulsion, so first is instantaneous speed. Instantaneous speed says कि speed of rocket at any instant of time. Speed of rocket at any instant of time. Speed of rocket at any instant of time, that is the instantaneous speed. So that equals to V equals to V0 plus U log M0 by M. So that is the instantaneous speed. V is the instantaneous speed. V0 is the speed of rocket at beginning of time. Speed of rocket at beginning. M0 is original mass. M is mass at a later time. That is instantaneous speed. Next is burnt out speed. Instantaneous speed, next is burnt out speed. Burnt out speed says कि speed of rocket when entire fuel burns out. That is the burnt out speed. So that is burnt out speed. Instantaneous speed, next is burnt out speed. So Vb equals to how much? Vb equals to V0 plus U log M0 by MC. That is burnt out speed. Vb equals to V0 plus U log M0 by MC. MC is the mass of carrier. MC is the mass of carrier. M0 is the mass at the beginning. That is burnt out speed. So instantaneous speed, burnt out speed. Next is thrust on rocket. So next is thrust on rocket. Thrust on rocket says कि thrust on rocket F equals to minus U. F equals to minus U into dm by dt. F equals to minus U into dm by dt. That is the thrust on rocket. So force exerted by burnt gases on the rocket. Force exerted by burnt gases on a rocket. That is the thrust on rocket. V relative dm by dt, V relative dm by dt, this is mg. V relative dm by dt, this is mg, and it moves with acceleration. V relative into dm by dt minus mg equals to ma. V relative minus dm by dt, V relative dm by dt minus mg equals to ma. Rocket moves upward with acceleration. So V relative into dm by dt, V relative dm by dt, so weight is mg, so moves with constant speed. V relative dm by dt equals to mg, V relative into dm by dt equals to mg. V relative dm by dt equals to mg. So in case of rocket propulsion, rocket moves upward with constant speed, that's why acceleration is 0. Rocket moves upward with positive acceleration, that's why acceleration is positive.